Well, since that didn't work out, I'll use this more cooperative chicken for reference. Alright, so we have here the problem statement. A chicken is drinking water from a trough that is 50 centimeters long and whose sides are equilateral triangles. If the height of the water is decreasing at a rate of 0.5 centimeters per second, at what altitude is the volume of water decreasing? At 25 centimeters cubed a second. At what rate is the surface area of water changing? And just to clarify, the surface area of water includes where it touches the sides of the trough and where it's exposed to air. Also, your first answer will be needed to solve the second part of the problem. In order to solve the first part of the problem, we need an equation that relates the volume of water and the altitude of the triangles that make up the sides of the trough. And that equation is volume V equals 1/2 altitude A times the side S times the length L. Unfortunately, we don't know anything about the sides of the triangle, so we have to do a little substitution. Since the triangles are equilateral, we know that each angle is 60 degrees, and therefore we know that square root 3 times the altitude is equal to 2 times the side length. With a little algebra, the side length is equal to 2 over square root 3 times the altitude. Once we substitute this back into the volume equation, we get volume equals 1 over square root 3 times altitude squared times length. Since the length will stay constant, we can plug in 50 centimeters before taking the derivative. After doing implicit differentiation with respect to time, we get the following. Now we can plug in what we know, which is 25 for dv over dt and 0.5 for dA over dt. After some algebraic manipulation, we get that the altitude is square root 3 centimeters. Now with the altitude, we're going to use that to solve the next part of the problem. First, we need a surface area equation, and that will be surface area, SA, equals altitude A times the side, S, plus 3 times the side times the length, L. Again, we're going to substitute 2 over square root 3 for S and 50 for L. So now the surface area equation looks like this. Now we can take the derivative, which gives us as follows. By plugging in what we know from the problem statement and doing some algebraic manipulation, we end up with 2 plus 100 times square root 3 centimeters squared. And so our answer is the negative of that number because the surface area is decreasing.